We're going to look at solving systems. There's three different ways that we're going to be solving systems. The first way is substitution. The reason that we know we're going to be using substitution is because we have a variable that's already isolated or by itself. So using substitution, we take the expression on the other side of the variable that's by itself, so the x minus 3, and we plug it into the variable. Since y is equal to x minus 3, we're taking our second equation and we're rewriting it so that instead of a y, what we have is an x minus 3. Now we're going to distribute the negative 2 to each of the terms. So we have 4x minus 2x plus 6 equals 16. We add the like terms, 2x plus 6 equals 16. We subtract the 6 and we get 2x equals 10. And x is equal to 5. Now we take this 5 right here and we plug it into one of the equations. I always like to choose the easiest one. In my opinion, that would be the first one. So we have y, instead of an x, we have a 5 minus 3, which we know is 2. So our ordered pair is 5, 2. Now, one way to check if this is correct is you could take the 5, 2 and plug it into the other equation. If I plug a 5 right here and a 2 right there, that would be 20 minus 4, which of course is 16, so I know I got it correct. The second method is elimination. We use elimination when we don't have a variable by itself. So if we look at letter E right here, notice that there's not an x by itself, there's not a y by itself. Now, in order to solve this, what we need to do is eliminate one of the variables. How we're going to do that is by opposites. So I'm going to take the numbers that I think are easiest, 9, 5, 3, 4. In my opinion, 3, 4 is a much easier number. And I'm going to see what multiple they both go into, and that would be 12. So 3 goes into 12, 4 goes into 12, so that's why I'm picking 12. If I were to look at my x's, that would be 45, which is a little bit larger number, so that's why I'm sticking with the y's. So I need opposites. I'm going to multiply this by 4, and when I multiply it by 4, what I end up with is 36x plus 12y, and 18 times 4, let's see, that's 32, 4, 5, 6, 7, so I have 72. Now, if this is a 12, I need a negative 12. So what I'm going to do is I'm going to make sure this is a negative 12 by multiplying it by 3. When I multiply it by 3, what I get is 15x minus 12y is equal to 30. I'm going to combine the two equations. Now, since I have opposites, whenever I add opposites, they eliminate. That's why it's called elimination. And now I only have one variable. So I add the 36 and the 15, and that gives me 51. And the 72 and the 30, which gives me 102. When I divide it by 51, I get 2. Now I have to plug it into one of the equations. I actually have 4 to choose from. I want to pick the easiest. In my opinion, it's going to be the first one again. But once again, you can pick any of them that you want. I'm going to plug it in there. 9 times 2 I know is 18. I'm going to subtract the 18, and I get y is equal to 0. So my ordered pair is 2, 0. Now, just like before, what I can do is plug it back in to see if it works. If I plug a 2 in there and a 0 in there, 5 times 2 is 10, minus 0 is 10. I know I got it correct. Now, the last method is solving systems of inequalities. And how we're going to do that is by graphing. First thing I'm going to do is I'm going to make my xy axis. With my first equation, my y-intercept is 1, so I plot a point at 1. My slope is negative 1, so I go down 1 to the right 1, down 1 to the right 1 again. I'm going to draw a dashed line. And since it's less than, I'm going to shade below. Now for this next one right here, first thing I'm going to do is I'm going to subtract the 2x. Now after I subtract the 2x, I'm going to divide it by -1. And whenever I divide by a negative, I flip the inequality. Now with this one right here, I'm going to start at -4 on my y-axis because my y-intercept is -4. My slope is 2, so I'm going to go up 2 to the right 1, up 2 to the right 1. I'm drawing a solid line, and in case you forgot from algebra, the reason that it's solid is because of the equal to sign underneath the inequality. So whenever it's equal to, it's a solid line, and because it's greater than, I'm going to shade above. Now my answer is always going to be the intersection of the two. And if you look at it, the intersection of the two is going to be this part right here. And that right there is my answer.